Alright, let's take a look at another thermochemistry problem here. This time it's asking me to calculate change in enthalpy using the units kilojoules per moles in a solution. So this one's going to be a little bit different here. First thing I notice when I read this is that I'm given two masses here. I have the mass of the solute and the mass of the solvent. So when I go to use my Q equals MCAT equation, I'm going to have to remember to actually add those masses together. But before I do that, I'm going to read this problem and just kind of look at a couple of key words. It says when a 12.8 gram sample of KCl dissolves in 75 grams of water in a calorimeter, the temperature drops. This is important. I'm going to box it in. There's our change in temperature. And then it says calculate, whoops, that should be a triangle, calculate the change in enthalpy for the process. So the whole point of doing this problem is to be able to get this value right here. We want to know the change in enthalpy for dissolving this solute. Before I even do anything, I like to look at what the temperature is doing, because whatever the temperature is doing is going to distinguish what my sign is going to be on my change in enthalpy. Because this temperature is dropping, that means it was an endothermic process, and you should have a positive value here for change in enthalpy. So before I even pick up a calculator, I'm going to just go ahead and put a plus sign here just to make sure I don't miss that, because I might get tangled up along the way. So for this question, the first thing I'm going to have to do is solve for Q. And to do that, I have to find the mass of the solution first. So just off to the side, I'm going to add up, 12.8 grams of my solute plus the 75 grams of my solvent. So really, the mass I should be using here is 87.8 grams. I can go ahead and plug that in for M. So 87.8 grams. My specific heat capacity here, I'm going to use 4.18 joules divided by grams times Celsius. How did I get that? That's just a number that you need to know. That is the specific heat capacity for water, and because this is dissolving in water, that's the specific heat capacity I'm going to use. And then my change in temperature, once you subtract, should be 9.4 degrees Celsius. Perfect. Okay, so once you multiply those three numbers and solve for Q, you should end up with 3449.8 joules. Wonderful. That's great. And that's a small piece of the step to help us answer the change in enthalpy here. Remember, the change in enthalpy is the units will be kilojoules per mole, right? That's what the problem's asking me to find. So now I have joules. Well, I can quickly flip that to kilojoules, plug that into my numerator, and then from my problem, I have grams of my solute. I can quickly flip that to moles and put that in my denominator. So that's exactly what I'm going to do. I'm going to do two kind of side calculations here. So I'm going to take I'll use a different color, my 3449.8 joules, and just quickly flip that to kilojoules. 1 kilojoule has 1,000 joules in it. So all I got to do is move the decimal point. Should end up with 3.4498 kilojoules. Okay, great. Now I can take that number, use it in my numerator. And then I have to convert my solute to grams. So I'm going to do another little side calculation here. 12.8 grams of KCl. Well, I can quickly convert that to moles. KCl, whoops, there we go. Divide by the molar mass. Once you look up potassium and chlorine off of your periodic table, you should get 74. And when you divide, it looks like you get 0.173 moles. Wonderful. Okay, now I've got those two values. I'm kind of running out of space here. I guess I'll just box it in here, show you what I'm going to do. Now I can take kilojoules and divide it by moles to get my change in enthalpy here. So I'm going to put 3.4498 kilojoules divided by my solute in moles, 0.173 moles. Wonderful, shabam. You should end up with something along the lines of 19.9, something like that. There are other ways to solve this problem. Actually, you know what? I'll show you how to solve it both ways. That way you can pick the one that you like. So once you get Q, instead of doing those two side conversions that I just showed you, you can kind of mash it all together in one long running equation here. So you can take 3449.8 joules and just flat out divide it by your mass, 12.8 grams of KCl, and then you can just kind of mash in those conversions all at once. So my next conversion, I'm just going to quickly convert from grams to moles. If I have grams down here, I have to have grams up top here to cancel. So I'll put 74 grams KCl for every 1 mole. Great, that flips me to moles, and I got to do one more conversion and convert from joules to kilojoules. So I'll pop that in there as well. Here your units do cancel. Whoops. You'll have joules cancel here, grams cancel here, and the unit you are left with is kilojoules per mole, which is the exact same thing that you did the first way around. It's just a different way of showing it. So if you punch this all in your calculator, you should punch in 3449.8 times 74 times 1 divided by 12.8 divided by 1 divided by 1,000, and you should get, yeah, that same answer, 19.9, and my unit again is kilojoules per mole. So this is the final answer here. If you got tangled up with the temperature and you might have accidentally put a minus sign there, that's fine. That's the reason why before I even did anything, I went to my delta H line and made sure, okay, since the temperature is dropping, I need a positive sign there. So that's just the way that I like to solve these problems. That way my, change in enthalpy matches if it's endothermic or exothermic. This was endothermic, so it has to be positive. This was a Rodriguez original production. I hope this helped you. Go back, study your notes, practice. Good luck.